Good morning, ladies and Will. Good to have you here today. Where did you leave off yesterday on this when I was gone? You started 12?
We're on 12. We just finished 11.
Oh, you just finished 11 and went to 12? So the video, you didn't watch the whole video is what you're saying?
No, we didn't have time.
Okay. Well, let me do this then. Then what we're going to do with this class is do 12 and 13, and then we got to go on something else, okay? So for this one, what are you going to do first?
X equals 2 minus 3t.
Yeah, so subtract 2, right?
Yeah, subtract 2.
So you get negative 3t equals x minus 2,
over
and then divide by negative 3, right?
t equals x plus 2.
So you have t equals negative 1/3 x plus 2/3. And so then you can plug right in here, right? So you have y is equal to negative 1/3 x plus 2/3 plus 5. And what I'm going to do is I'm going to rewrite 5 as 15/3. Why do I want to rewrite 5 as 15/3? To get to common denominatorize. So 2 plus 15? 17/3. So that's what you get for your rectangularized equation, right? And then we can take to graph this thing, what does that look like when we graph it? So it's gonna look like let's see if I can get it more horizontal looking. That's a little better. Okay, so we get this one, it's like 5 2/3, right? That's 5 2/3. And then we have our slope of the line going to go like this. Something like this. Is that right? And then to check, we can go to our calculator and go to parametric mode.
For some reason yesterday, our calculators worked, or mine wouldn't work.
It wasn't working right?
Yeah, I wouldn't graph anything.
Oh, really? You think the windows were messed up or something? It could have been, because I had some problems in 5th period with windows being messed up. That could be an issue. But let me go ahead. I want to turn off the plot because I'm getting for tracing a messed up thing here. So I'm clear. So over here, what we have is, we have 2 minus 3t and 5 plus t, right? 2 minus 3t, and then 5 plus t. And then you got sometimes it could be your window that's messed up here. So what you can do for that is you can go to zoom 6 to get a standardized window. And that's a standardized window right there. I don't know if that helps you on this thing. And then what happens is you're going from 0 to, your standard is 0 to pi over 2. So I can go to negative 2 pi and see what happens. And see what happens when we graph there. Yeah, we get more of the, but that's where it is, right? 5 2/3, slope of negative 1/3.
Yep.
And the rectangular version of the equation will give you the same thing, right? Okay, what I want you to do is go ahead and do number 13. Can you go to do that? Go to number 13, similar type of problem. I'll just leave, I can just leave that there. Do this. Now here, what they have on number 13 is they do have a domain restriction, yes.
Can you come look at this real quick?
I'll look.
You can do these.
Sorry, I don't know when you should do that.
Just don't.
This part here.
Please, don't. You do.
That part, is it,
Oh, okay, yeah, what you do,
Is it going back to the circle thingies?
yeah, what you do, what I go is I put it into the x equation, and you kind of see the starting x value. And then you take the 5.
Sure.
So basically, let's show you what Kayla's asking me. That she basically solved it all for y, but then she asked what to do with this 3 and the 5. Well, the thing you do is you take that 3 and plug it in for x, and you're going to see where the thing starts.
Miss G, I got this one today. I got it.
Oh, you got it?
Yeah, I got it. What else can you cover me?
So you want to do this one?
Yeah, I'll do it right here. Sorry.
Yeah, that's fine. I'm all for that.
Hey. All right, so are we on kind of style answer or are you going to work it out?
What-
Okay, so I did x equals 2t minus 3, and then I added 3 on both sides, and then I got x over 2 plus 3 over 2.
Like this?
No, not like that.
That's x over 2 and 3 over 2.
Okay, and then you put equals 2t over 2. But you did it, it's over there where your 2 is, or your t is. Yeah, that, it's gonna be 2t over 2.
Oh, 2t, so you cancel out, right? So you canceled out, right, to get this, okay?
Yes,
I see what you're
yes,
saying.
yes.
So you're holding me accountable for all the steps is what you're doing,
You were
okay?
going all the way, Mr. G.
No, she's held me accountable for all the steps. I can't argue with that, or don't want to.
No.
All right, good.
Okay. And then, so we got the t equals x over 2 plus 3 over 2. And then, that's that top one, you know?
You go
And
here.
then we're gonna do x equals 9 minus 4. And in parentheses, you're gonna do, x, yeah, that, hey, looky there, you already got it, Mr. G, you knew what I was saying. And then we're gonna do y equals 9 minus 2x minus 6 plus 3. And then you get y equals negative 2x plus 3.
Okay.
And then you get, oh, that should be nice.
So basically, she's given me the rectangular form of this, right?
Yeah.
So she did a rectangularized version. So let's go ahead and graph this and what it looks like, and then we're going to get to Kayla's question, which is a very good question too. So you go with negative 2x plus 3, that's going to be y-intercept up here, right? And so it's going to be, I'm going to put it in blue. So you got negative 2x,
Mr. G.
so things going to go like this, right? Yes. So that's what it looks like, right? This is going to be 3. That's your y-intercept, and that's what the graph of it looks like, a rectangular version. Now, we come thinking, that was really good work.
Like,
Now we have is what Kayla was asking, what do we do with this 3? Excellent question. So what you can do is you can plug in 3 for t. So if you plug in 3 for t, what do you get?
X equals 3.
You get x equals 3, which means that for the purposes of where this thing actually shows up, you start here at x equals 3, you're going to start right here. And then if you plug in x equals 5, what do you get?
X equals 7.
7. So then it goes down to x equals 7. So what you're doing is that the actual thing, when you look at it, is just this part of that line and going in this direction. Does that make sense? That's an ugly looking arrow though. But that's what it is. And then you can graph that in the calculator, 2t minus 3, 9 minus 4t. 2t minus 3. 9 minus 4t. And if you go to zoom 6, I think it's already, So it's gonna look like this, but let's go ahead and restrict, like Kayla was telling us, right? From 3 to 5. Let's go from 3 to 5. What's it gonna look like? Well, we can't see the whole thing. Let's change the window, and we're gonna go ahead and make the Y minimum, I don't know, -20. There it is. So I want to thank Kinsey on this one, and Kayla. That is some excellent work. Go ahead and do number 14. Can you do that? That's a restricted domain one too.
I didn't do it yesterday.
What did you just do to yourself? Oh my God.
Okay, I'm gonna call on somebody today for number 14. And that person is gonna be Hannah. I got you for number 14, Hannah. Okay, Hannah. I didn't want to clear that. That isn't what I meant. Okay, go ahead.
I did the x equals 5 minus 13, subtracted 5 to the other side. So it's x minus 5 equals negative 13.
X like this.
And then I divided the other side by 3. So it's negative x over 3 plus 5 equals 30.
So you're gonna get this right. You're gonna get that, and then you plug in for this.
And I plugged in and I got y equals 2 plus negative x over 3 plus 5 over 3. But I changed the 2 to 6 over 3.
Okay, that's good. So you did the, okay, so you did that, you replaced that with 6 over 3
Yeah.
plus 5 over 3.
And then I got y equals negative x over 3 plus 11.
I put t, it should be x, right? So we have negative 1/3 x plus 11/3, is that right? Okay. So when you graphed, you got 11/3, which is up. Okay, so 11/3 is up here somewhere. That's like, was that what, 3 2/3? That's 3 2/3,
3
right?
and 2/3.
And so the thing goes like this, doesn't it? Something like that. And then, how'd you count for this -1 to 3 business here? How did that work out? Did you do that yet?
Don't you just do -1 on the line and then 3 on the line?
You gotta plug it in.
Yeah, you gotta plug it in here.
Oh, then I haven't done it yet.
So let's go ahead and do that. So if you plug in -1, so we get 5 minus 3 times -1, that's gonna
It's
be,
gonna be 2. Right?
well, you have -3 times -1,
Which is 3.
so that's gonna be 8, right? Because you have minus and negative. So x equals 8, so you're starting right over here, right? And then if we plug in 3, what do we get?
Oh, I thought we were plugging in for X, my bad.
Well, we're plugging in for t. So you plugged in -1 and you got x equals 8. So here you have t equals -1, x is equal to 8, right? And if we plug in 3, what do we get? Five minus 3 times 3?
9, -4.
-4. So here, over here, we're going to have t equals 3, and we're going to have x equals -4. And then we can test this out in the calculator, right? 5 minus 3t, 2 plus t. So 5, I don't know what happened, what I did to my calculator. Okay. Look at it again. I don't know what I did in my calculator, my poor calculator. Okay, 5 minus 3t, 2 plus t. 5 minus 3t. And then down here, 2 plus t. And we graph. I'm going to go to zoom 6, get a standard window. And I haven't changed the window yet, right? I'm going to go from, it's -1 to 3, isn't it?
Yes.
So now we graph. So that looks perfect, right? So here we have t equals -1 all the way up to t equals 3, and you can trace. And if you trace, you start here at t equals -1 and go in this direction, right? So that means our arrow is going like this. Okay, good work. What I want to do is, that's as far as I want to go on this sheet here. I want to work on some other exercises. But on this, so I don't know how far we're going to get on this today. But I want to get through these today so we can start working on real world parametric equation problems starting on Monday. Oh, okay.
William asked me
I thought she was telling me the truck, so she called me a fat man. I said, well, yeah, I have gained some weight, but
He said, maybe not that bad.
what I did yesterday is I went to the dentist and had to pull a tooth out. Yeah. So I'm gonna have to have like a dental implant. But then I also replaced the
Mr.
drive.
D.
I feel better, yes.
Quick question. Did I do these right? Because we're about to do the same thing on these.
Can we
Oh, really? Yeah, I don't
change
want, because we don't have much class time. I really want to blast on this page.
Blast on this baby.
Oh, yeah.
Okay, so what I'm going to do is turn to the back page here where we have number 23. Can you go to 23?
23.
It's on the back page, 23. So 23 here, it says eliminate, same instruction, eliminate the parameter, identify the graph of parametric curve. Okay, how are we going to do this?
You divide by 5?
Yeah, so we have x equals 5 cosine t. Let me get this right. X equals 5 cosine t. And if we're solving for t, yeah, I'm with you. We divide by 5. So cosine t equals x over 5, right? Are we okay to there? Okay, and then solving for t, what are we going to get when we solve for t?
Divide by this.
Okay, remember we can't do that. T is going to be equal to what?
Inverse.
Elizabeth,
The inverse.
what'd you say?
Inverse cosine.
Inverse cosine, right? So inverse cosine. So Kaylee gave me that one. Thank you, Kaylee. And then what can we do with this? Plug it in here, right? So we have y equals 5 sine inverse cosine of x over 5, right? And let's graph that in the calculator, see what it looks like. And to do that, I need to get back into my regular mode, right? I got to make sure we're calculators in radians. So over here, we have this typed in, don't we? I don't know what I did to my view screen to mess that up. But anyway, if we graph, this is what we get, which is what?
Bridge.
A half circle going from 5 to 5.
It's really a half circle,
Gotcha.
Ellipse.
and it looks like an ellipse, but really it's a circle.
Oh.
Do you see why, Will? Because of the distortion of dimensions. And when you want to have your dimensions regularized, you can go to zoom square, which is zoom 5, and zoom 5 will regularize it, okay? So we get half a circle out of the deal, right? So that's what you can do to eliminate the parameter. But really what's happening is it's going to be plus and minus. And I don't have time to really explain. It's going to be that and negative 5 sine cosine. It has to do with limited domain of an inverse function is what it has to do. So if you type these two in together, you'll get a circle, essentially. But what I want you to do is we're going to kind of put this aside, this method here. I want to show you another method that involves another aspect of trigonometry we've gone over this year. So I'm going to erase this and pretend like we're starting all over on this problem. And in this starting all over is really how I want you to solve these other ones today. And what it is this. Do you remember something like this? You remember something like that? If we wrote x squared plus y squared equals 1, what we have is we have an equation of the unit circle. This is your equation of your unit circle. So what this is a more generalized form where you have a radius. So this could be any radius here, right? So let's go ahead, we're going to take this and replace x with this. Do you see that? So we're going to go ahead and take 5 cosine t, and we just replaced x, didn't we? And then we're going to go like this and put 5 sine t, and then we have that equal to r squared. Okay, what happens when we square things out here? 5 squared is
25.
25. So you have 25 cosine squared t plus 25 sine squared t, that's a 5. Almost looks like an S. Sine squared t. And on the right we have r squared. What we're going to do is we're going to end up solving for r soon. Okay, what can we do with this on the left? Do we have a common factor here? Do we have a common factor between 25 squared cosine squared t and 25 sine squared t?
25.
25, thank you, Kayla, all right. So if 25, it's going to be 25 times cosine squared t plus sine squared t. That's going to be equal to r squared. Okay, what is cosine squared t plus sine squared t equal to? What is cosine squared t plus sine squared t equal to?
0.
1.
1, right? But you knew that already, right?
Yep.
Yeah.
It's on your ACP formula chart. We're talking about the Pythagorean identity. Yes. So 1, so what can we do to this thing? We can simplify it. And this cancels out to become 1, doesn't it? So what do we have left? 25 is equal to r squared. And so what is r equal to? R is equal to 5. Thank you, Carmen. Okay, so what we have here is this thing here, a radius of 5, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we have this a circle, it looks like this. Except it looks a lot better than that, right? So on your calculator, you can just put in your calculator as, I got to go back to my parametric mode. So we got 5 cosine t over here 5 sine t. And we graph this thing. I'm going to go zoom 6. And that's what it looks like. Okay? Yeah, and if I go ahead to zoom square, that will square it up. Okay? One thing you got to be careful about is if you don't have in your window a full circle, let's say we had, instead of going to 2 pi, let's say instead we went to pi, what are we going to have?
Half circle.
A half circle. Okay? So it's 0 to 2 pi that enables us to wrap it around the whole circle. So what I want you to do is the next follow-up problem, which is 24, which is quite a bit like this one. I'm going to see if I can, I don't know what I did to mess up my, oh, I know what it was. There, that looks better now. Okay. I was getting worried. I thought I may have permanently damaged my calculator. But for the viewers, one thing that I showed as a visual aid was this Pythagorean identity T-shirt. See right here it says 1 equals sine squared theta plus cosine squared theta. And on the back we have John 11:17 with the words 1 substituted.
Participation.
All right. Okay, number 24. Okay, number 24, we have, it's going to be Emma or Will. It's Emma. So you have 24, Emma? All right, Emma. Okay. What happened on 24?
Listed the, tried to do the same thing on the other one that you did at the end, but I don't know if I did it right.
Okay, let's just go. So did you do like this? Did you write it like this? 4 cosine t squared plus 4. Does this look familiar?
Yes.
Equals r squared, like that?
Yes.
Okay, so we're good now. So that's going to be 16 cosine squared t, right? Plus 16 sine squared t equals r squared. Is that right so far?
Yes.
Okay. And then,
I put the 16 on the outside.
so 16 goes like this, right? And that's r squared. And this simplifies to? This simplifies to 1, right? So you get 16 equals r squared. So r is equal to? 4. All right. And really that's it. So now you have just a circle, right?
Yes.
Like the last one.
It just goes 4 each way.
Now I want to show you something that was interesting, that was brought up in 5th period class. I think it was Elizabeth who brought it up. Says, are these numbers always going to be the same? Not necessarily, right? So let's go ahead and do that. Let's say we made that 4 cosine t and 5 sine t. What's going to happen there? So here we go. 4 cosine t and 5 sine t. What's going to happen here? An ellipse, right? And then your ellipse will be different depending on what happens here. And this sort of brings into, very last thing I think we're going to have time to just go into briefly at the end of this year, are conics, including circles, ellipses, hyperbolas, parabolas. And so in trigonometry, that's how we get there. So, and I don't know if you go over here, if you look where Carmen is, right up there,
Batman.
that's something we did in, no, the other way, up here, what I wrote, not what you wrote. No, the black, stuff in black. What is, that's equation for ellipse. That was actually from calculus, and it's worked out to be an ellipse that has a certain dimensions. So you going ahead and doing number 25, I hope. So you're working out number 25, I hope.
This is big text right here. Big text. Big text. No. Good.
What would you rate my drawing?
Okay, 25. We have, it's gonna be 25. I got you, Carmen.
Carmen, it's you.
25. Carmen might draw a cartoon of a fat man. There. So Carmen, 25. What'd you get for 25? The fat man? No, I can't. You have to be the expert at that.
Sorry.
Carmen's on the next one.
Okay, so Carmen, what, 25, what did you do, what did you get for this one?
Can we feature big text on the video?
No, 'cause here, the reason I can't do that is because of this camera is sort of, it's sort of in settings, it's the geometry of it. To turn it around, it'll sort of mess it up.
Can you take a picture and put it as your like thing, like when you open your YouTube, like this is big text, like it's the start of your video.
Oh, it could, yeah, I could do that. But that's a lot of work to do that, because then I have to edit videos and put it on there.
Your cover photo.
But it's just the work of it that is too much. But it's, okay, Carmen, what'd you
You
get?
have to pay extra.
I have time. I read it. Okay.
Almost done, she says.
Shut up. Yes, I am.
And what I'm going to do at the end of class today, I'm going to want you to turn in all the work you've done yesterday and today.
That's a lot.
It's quite a bit, yeah. And then what we're going to do is Monday we're going to go into real world. Yes, Carmen, go ahead.
It's R equals 2.
So she gets R equals 2. So you worked it out to R equals 2. So it's going to be like this, Carmen, something like this. But drawn more neatly, right? Now one thing that's not apparent here, and we're out of class time, is this between 0 and 3 pi over 2. What it's going to do is going to start right over here. It's going to rotate instead of counterclockwise. It's going to rotate like this. And it's just going to go to right here. Okay, and then 2 sine t, 2 sine t, cosine. So 2 sine t and 2 cosine t. And then window, we go from 0 to 2 pi over 3. No, not 2 pi over 3. Yeah, 2 pi over 3, that is right. So we graph, this is what we get, except that's not right. What did I do wrong? 3 pi over 2. So anyway, yeah, turn in everything you have. 3 pi over 2. So that's what we get.